The world of spacecraft is undergoing a rapid change currently. It used to be that NASA would launch very large spacecraft that would take years to develop. But now we have a new generation of satellites that are very small, take much less time to develop, and can be launched much more inexpensively. Components are available to build these spacecraft, but many of these components have not had a lot of time to be flown in space. So one of the things we're really interested in is how can we test out these smaller components, and how can we have as much confidence in these spacecraft components as possible before we launch them into space. GNAT is the Generalized Nanosatellite Avionics Testbed. It's basically a testbed where we can bring together all kinds of hardware components and software components that would make up a very small satellite and test them out to give us a better sense of how they may act in space. One of the things we try to do with spacecraft on Earth is to simulate some of the environmental factors that we will encounter when we get up into space. For instance, a few of the things we would like to try to simulate on Earth as closely as possible is the ability of the spacecraft to spin in space around various degrees of freedom, and also the magnetic field that the spacecraft may encounter as a spacecraft will, say, rotate around the Earth. There's many things that we can learn from these tests. The first thing we can learn is how all the components of a spacecraft may work together and how those components react to the simulated conditions of space. One of the best things about the GNAT project has been the involvement of our students here at UC Davis. Our students have had the opportunity to contribute to the development of the GNAT testbed through working on both hardware and software, extending the things that they're learning about in their classroom to an actual physical hardware testbed, working with NASA scientists.
On the GNAT project, we're trying to develop another system that we could use as a truth for testing the primary magnetism attitude determination system set up on the current testbed.
To give the researcher a second data set that can tell them the orientation of a certain object on the testbed.
We're going to be using a visual system using computer vision to take a picture of something similar to a QR code to determine the attitude of the testbed, which is then compared to the attitude determined by the magnetic field. At this point in the GNAT project, we're almost finished with our algorithm to determine the attitude using visual cues.
We can get the estimations of the object, then get the orientation.
The next step is to finish our validation and make sure that the system we're using is accurate enough, and then applying it to the actual testbed itself.
The hope for a testbed like this is once we are able to test out many of these individual components that would go inside a small spacecraft, later on when we decide to change or build a new small spacecraft, we can take bits and pieces that we've already tested in the past so that we can even further accelerate the design of new spacecraft in the future. We've had a wonderful relationship with UARC, UC Davis, and NASA Ames. Many of our students from several labs here at UC Davis have now worked on the GNAT testbed, and we're hoping that many more students in the future will be able to participate in developing GNAT and also using GNAT as more and more features come online.